Hi, everybody. I'm going to get you ready for your Unit 4 alternate lab on waves. So I just wanted to review some terms with you just so you are a little bit familiar as we head into that lab. Um, it's, I don't know, I enjoy all the labs, so I guess that doesn't say a whole lot. So there's the two type of waves. So we have longitudinal waves. So that's when you have like a spring, like a slinky is something that you can think about, where it goes back and forth, and then they have interference. And so you can see how it gets like pushed together and spread far apart. So those are like your compression waves and refraction waves. But the main wave that we'll be working with today is a transverse wave. So that's kind of the wave that you really see like on the ocean. So the property of these waves, or the properties, we have our amplitude. So we have our equilibrium line just kind of going through the center of our wave. And so the distance from that equilibrium line to the crest, which would be the very peak of the wave, the very top, is the crest, would be your amplitude measurement. You can also find that by going from the equilibrium line to the trough, which is the bottom of the wave, or the lowest part. So the period is the time that it takes to do one cycle or wavelength. So how long it takes just for one wavelength. And it's in units of seconds. Our frequency is determined by that, but typically we'll do have the period be like 1 second. So then we'll measure the number of waves per second. So that'll be your frequency. So you could have like 3 waves in 1 second or 1 wave in 1 second. So that's your frequency. And then your wavelength. Ooh, sorry. Just barely touching my mouse. It's jumping all over. Is from one point in the wave to the same point. So it's easiest, I think, to do either the peaks of the waves, so the crests, or the troughs, but you can try to find a point elsewhere and try to match it as well. So as long as it's at the same point, or here, one down, one up, you can go by the equilibrium. So I like to do that also. So yeah, we're gonna get going. Here's a little hint. So if you have a low or a short wavelength, you tend to have higher frequency. So notice that it's a little bit opposite, and that's called inverse or inversely related. So if you have a really long wavelength, that usually means that it's a lower frequency. And again, you can think of the ocean. If it's like short and choppy, there's a lot of energy, and it's high frequency, stormy or windy. If it's nice and low and slow, it's a nice calm day. You have a lower frequency, in your wavelengths, high or long. So just a quick quote before we jump into our lab. Physics has found no straight lines. Instead, the physical universe consists of only waves undulating back and forth, allowing for corrections and balance. So that's something kind of crazy to think about. That light's a wave, sound's a wave, like vibrations and everything around us, energy waves. But it's pretty cool, and it helps us understand everything around us. So that's why we're learning about it. So you'll go to your lab. You'll click on your virtual lab, open your lab document. I did add a nice long video walking you through. So this is kind of the shorter video assignment project or one right now. But if you want to watch, like really be walked through a lot more, you can click on that. And here is your lab that you'll be working on. So we'll click on that. click the arrow to get started with our simulation. And I already read the directions, so we're gonna want to go to oscillate, and we want to set our dampening at none, and we want to have no end, because that creates some interference. It makes kind of the wave goes and hits and comes back, and so they overlap. You can play with that at the end too. But right now we just want to look at some different things like our amplitude, frequency, and wavelength. So the first thing, you'll describe what you're seeing right now. And then next you'll go to part 3, question 3. And you'll go through some of these different amplitudes, frequencies, and you'll determine what the wavelength is and write a description, or you do a screenshot or draw what you're seeing. And it's just an estimate. Whoa, wrong thing. Guess I should close it. Okay, so we want to have our ruler. You can also have a reference line if you would like. And I did discover that you can adjust these rulers. So if you wanted to measure here, so we're already on the first one, so we just pause it. You can go ahead and measure peak to peak, or if you would like, you have the midline, so you can go along that. So it's one wave. So you get it to be right around 4.2. Or you could go peak to peak, whatever you prefer. And again, still right about 4.2. And you can also see what the height is. So I would move that over to get to your peak, or you could do it based on the trough. Make sure you have it on the 0 line, and that's right about 0.8, or it should be 0.75. It goes slightly above. So yeah, that's that first one. I'm gonna try to go through this quickly. You're welcome to watch the longer version, but that's essentially what you're doing, and you'll draw your wave just so you have a good idea. So really what this is showing us, we have our amplitude here. Notice what changes, our height. So we can go up 1.25. You measured it, it should be pretty close to 1.25. That peak there, so if you paused it, you can get that. Here's your little thing. There we go. Yeah, that's pretty close to 1.25 because this is 0.2, this line. It's 0.2, 0.4, 0.6, 0.8, and then the 2. So you can lower your amplitude, not quite to 0 because then it doesn't show a whole lot. You can do as low, well, we really only in the table go to 0.5 centimeters. So you can see what's happening there. Notice the difference in energy, maybe how fast this little wheel is going. Imagine that's your crank to get it to go. That's how much energy you're having to put in to create that wave versus notice how quickly you're having to do it to get that lower wave. Same thing as if we change the frequency. Now all of a sudden we have 3 hertz. So we are doing 3 waves per second is what we're doing essentially. So if you paused it, you can kind of count 1, 2, 3. So 1, 2, 3 right as it's exiting. Or you could do your 1, 2 equilibriums, 3. You can slow it down if you would like, but just to get a sense of like the real energy, I'd say keep it at normal. And then we can lower it all the way down, almost down. I think we leave it at 1 because we want 1 wave per second. And so you can see how maybe that might have some reduced energy there. Notice your difference in amplitude, and you'll be measuring the wavelengths and see what changes. Is it the amplitude that affects the wavelength? Is it the frequency that affects the wavelength? And so those are questions that you'll be answering in this lab. So you're welcome to play with it beyond just trying those out, but that should give you a really good idea of how they interact with each other. And that's what you'll be describing down here. How the frequency affects the wavelength. So you'll look at your frequency. How does that change your wavelength? How does the amplitude affect the wavelength? Okay, so our 0.75 versus this versus the 1.25, did that change the wavelength, or was it just the frequency that had an effect? And so that's kind of what helps when you have some of the ones that are like the same values, to see, oh, is it the amplitude affecting it or the frequency, or is it both? And then changing the amplitude, how do both frequency and amplitude affect energy? So I kind of talked about that. And then the amplitude of a wave is related to the energy of the wave. Did you see anything that made you think you could prove your point? Or how could you demonstrate this relationship? So yeah, you could just show, be like, you could show from the graph above, you can describe a scenario, you can take a screenshot of your lab, however you would like to prove that. And then discussing your relationships. I know we just talked about one of them being inverse, so maybe mention that. And just looking at your table, or you can go back to this and play with it. See how they interact, see how the amplitude, maybe having a low amplitude and a high frequency affects. Maybe do they affect each other? Do they affect the wavelength? That kind of a thing. So you're the scientist here. You're discovering these things, seeing if you can understand how they relate to each other. So just explain in your own words how, like we gave you a kind of a writing prompt here. So as frequency is increased, what happens to the wavelength? So you're kind of taking these things that we discussed up here and putting it in a summary essentially on number 10. So I hope that helps, and good luck. Let me know if you have any questions, and yeah, reach out.